Oh, that's better. I'm just kidding. Welcome back. See, you all survived doing the homework last night on a nice rainy day. Maybe, I don't know if it's rainy or not. Anyway, here I am. We're going to look at Chapter 5, Section 2, which is about, you can see that right there, polynomial sums and difference. So first we have to define a polynomial. But a polynomial, this is a general thing. We can think of as a polynomial as a term or monomial. These are the monomial or a term. A term is part of a polynomial. Nomials meaning a thing, a single thing. So x, that's a monomial. 16, that's a monomial. It gets really weird because 16x is also considered a monomial. So in a way, what can you say about monomials? They're either something by itself or something multiplied by something. So 46, x to the fourth, y to the third, z cubed, q to the ninth. This is still just a monomial. Yeah, all of that's still just a monomial. Because it's all it is, it's multiplication. This is considered, let's make it a little simpler now. So if we have this part is called the what? We've been dealing with it in earlier chapters. Coefficient. Coefficient. You didn't know that I could speak French, did you? Oui, monsieur. I can't, so I'll quit. Coefficient. This is called the coefficient of x. That's still a monomial. How about this number? 33. Monomial. What's the coefficient? 33. A number is a coefficient of itself if it's by itself. Now back to something yesterday. What is invisible in front of it? A 1. Yes, a 1. So even though x by itself is a monomial, there's still an invisible 1 in front of it. Invisible 1. You see it? Okay, so it's not there. So that's the first thing you need to know. That's the idea of monomials. But we can also talk about polynomials. This is more like the general term for it, polynomials. So one of them is, well, we already talked about it. This is a monomial because it only has one nomial, one term. What happens if we have 16x plus 3? What do we call that? I heard somebody say it, binomial. It's what they said when nomial left the room. Binomial. Okay, that was a bad one. What happens if we have 16x squared plus 3x minus 2? Easy. 1, 2, 3. A try, not a thri, a trinomial. Now, after that, we could call it a quadrinomial and a pentanomial and a hectanomial and an octanomial, but we don't. After this, we just use the term polynomial. But there's other ways of identifying this, and this is the next part on the next page. I didn't give you the page number. Look it up, you can find it. Where we actually classify. And I'm trying to talk fast because YouTube will only let me load up a certain amount. You probably noticed you had to see 2 parts of the other one. So we can classify polynomials. And how do we classify them? By number of terms and degree. Degree refers to exponent. So that 16x squared plus 3x minus 2, I think that's what it was, would be considered a trinomial of degree 2. Or we could say a second degree trinomial if you wanted to. You could word it that way. Another example. 12x to the 9th plus 2. 12x to the 9th plus 2. It is a binomial. There it goes, leaving the room again. Of 9th degree. 9th degree. Okay? That's that part. I think you can figure it out. That's on page 282. Well, guess what? You can also add and subtract polynomials. So I'm just going to look at the example here. It says to add 5x squared minus 4x plus 2 and 3x squared plus 9x minus 6. The way you want to do it is this whole idea of like terms. I know you've heard this stuff before. Like terms. So what are like terms? Well, we want to talk about like terms. 5x squared plus 3x. Forgot to say over here, add. I said it in words, but there it is printed. Plus negative 4x plus 9x plus 2 plus negative 6. And then you literally combine like terms. So let's do that real quickly. 8x squared, negative 4x, positive 9x, plus 5x. 2 minus 6, negative 4. So this would be considered the sum, result of adding these two polynomials. Subtraction. I'm skipping over to another one. Because you can do example 7, you can see that yourselves. Here's example 8. Example 8 says to subtract. Subtract 9x squared minus 3x plus 5. And we're subtracting. So I put things in parentheses just as a reminder. Minus 4x squared plus 2x minus 3. What does that actually become? That becomes 9x squared minus 4x squared minus 3x minus 2x plus 5 minus negative 3 plus 3. 5x squared minus 5x plus 8. Always look carefully. Look carefully on this one. It says to subtract A from B really means B minus A. Subtract A from B means B minus A. So when it says subtract 4x squared minus 9x plus 1 from negative 3x squared plus 5x minus 2, example 9, it gets switched like this. Also, and I'm rushing here, 4x minus 3 times the quantity 2 minus the quantity 3x plus 4. You got to be careful in terms of brackets and parentheses. We need to deal with this part first, and then deal with this part, and then deal with this part. So what do we have? We have 4x minus 3 times the quantity 2 minus 3x minus 4. That negative applies to both of them. So we get 4x minus 3 times negative 2 minus 3x. And then we distribute. So we have 4x plus 6 plus 9x, which is 13x plus 6. And that is example number 10. The last thing, example 12. Well, not example 12. Remember that when we can deal with functions, these are the most important functions that you will see in the business world, basically. There's a whole lot of others, obviously, but these three we've already dealt with as functions. You can add and subtract functions. You can add and subtract functions. We've already seen that. So if we had p of x was equal to 5x cubed minus 3x squared, hopefully I'm not blocking it, plus 4x minus 5, and we wanted to know what p of 2 is. You remember what to do? You substitute. So you end up with 5 times 8 minus 3 times 4 plus 4 times 2 minus 5. 40 minus 12 plus 8 minus 5. 48 minus 17. 31. Did that quickly. Take a good look at it, see if it makes sense. All right. That's basically it. Example 13 you can work on your own, but basically it follows this principle. P of x, the profit, equals the revenue minus the cost. And if they give you the revenue function and the cost function, you add the two functions together, the two polynomials together, create a new polynomial, and then the next thing might be, well then, if that's the case, what's p of 100? What do? Substitute 100 for x in whatever you get when you do that. And that's the end of that. However, homework is page, and I will post this on School Loop, page 286 to 288, 1 through 12, 14 to 84 by 4s. As I said, it will be on, well, I like red for School Loop. I don't know why. Because it's a bloody good show we're having here, you know? A bloody good show. I hope you have been entertained. Okay, that's a lousy British accent. So anyway, there we go. That is chapter 5, section 2.